This example, we're going to go with dividing rationals and finding excluded values. So remember I told you that I wasn't going to do finding excluded values and simplifying and then multiplying and finding excluded values. I'd just rather go over dividing rationals because it's the same thing. Just have to do a couple extra steps in the beginning. I remember when you divide, I told you guys that KCF. Remember, K stands for keep the first fraction the same. C stands for change the operation from division to multiplication. It's a lot easier to multiply fractions. And then F means flip. So flip the second fraction. Keep the first one, change the sign, flip the fraction, KCF. So this is the expression that we're going to work with. So it's obviously we are dividing these two fractions. We're going to go through with step one. That's the KCF. So keep that first rational expression the same. Now we're going to change the sign from division to multiplication, and then that back fraction we're going to go ahead and flip it. So 10n squared plus 5n is in the numerator, and then 8n plus 4 is in the denominator. So we're at this point. So now what we've done is we've taken it from a division problem to a multiplication problem, multiplying a heck of a lot easier. All right, so we're going to start to keep going on with this second part. All right, it's going to be factoring. Now remember, when we factor, we're going to actually be able to, we're going to simplify, right? But we're going to go ahead and just make sure that we factor first. All right, so this is the expression that we were working with. First one, you have four parts. You have a numerator and a denominator for the first fraction, numerator, denominator for the second fraction. That numerator for the first one, 12n minus 32, that's GCF. 10n squared plus 5n, the other numerator, another GCF. 8n plus 4, another GCF. And then that last one, 3n squared minus 2n minus 16, you're going to use your box. Now, I'm not actually going to go through the box method. There's examples up there. There's other videos. Watch them. Learn from it. Figure out how to be able to factor. The others are GCFs. That's greatest common factor. Greatest common factor for that first numerator is going to be 4. So factor out the 4, and you're left with 3n minus 8. The denominator, I'm going to use the box. And when you use the box, you get 3n minus 8 and n plus 2. Now we're going to go to the other fraction. We're going to multiply. We're going to multiply by that top numerator and denominator. We're going to factor a GCF from the numerator, and the numerator GCF is 5n. So you're left with 2n plus 1. And then the GCF for the denominator is 4. We're going to factor that as 2n plus 1. So this is where we're at right now. So we did our factoring. Third step is going to be canceling common factors. So when we cancel common factors, we're also finding excluded values. All right, so we're going to go ahead and rewrite our expression. And hopefully you are already able to see what is happening with this stuff. You're going to be able to see the common factors that we can go ahead and divide out. So I see a 3n minus 8 that can get divided out, a 2n plus 1 that can get divided out. I also see some numbers that we can go ahead and divide, and those are the 4s. So what's left over is 5n over n plus 2. That is our simplified expression, so that's part of our answer. The other part is finding all these excluded values. Well, remember, when we're simplifying, we're actually starting to find some excluded values. So the first factor that we divided out was 3n minus 8, and the other factor was 2n plus 1. Basically, remember, to find excluded values, set them equal to 0 and solve. So the first one would be negative 1/2 and then 8/3. So we have two excluded values because we divided out two separate factors. All right, so that's our next part. Last step is our denominator. So we want to make sure that values that make our denominator 0, those are going to be excluded values as well. So our simplified expression right now is 5n over n plus 2. The n plus 2 is what we're really interested in. That is going to get our last excluded value. So when you set it equal to 0 and solve, you get negative 2. So I'm going to write down our answers. Our simplified expression is 5n over n plus 2. And then our excluded values is the negative 2. That was from my denominator. And then from the factors that we divided out was 8/3 and then negative 1/2. Right? And that's our problem. Now remember, if it's just simplifying and doing our excluded values, that is, you get rid of the KCF. If it's multiplication, you're not doing KCF. The only time you do KCF is if you're dividing. It's easier to multiply fractions, right? But this is kind of like how you want to work with it. Right? You want to simplify. You want to do some factoring first. Divide out any kind of common factors. Look and see what's left over. Do I have any denominator that can be set equal to 0? If I can, I'm going to go ahead and make that an excluded value as well.